What's the farthest north you've ever been?
I've been to DC, actually.
DC's not very north.
Huh?
Yeah, I know. North.
North, yeah. Washington, DC. Yeah.
It's not that north.
I mean, it's further north than most stuff.
I think it's more agonizingly boring.
Oh, yeah.
Skipper. This is
I must already
I'm like 99% sure I turned it in.
Well, it'd either be there or in your binder.
I don't.
I don't keep
I
papers over here that y'all turn in.
What do I do?
I think I turned them in already.
I don't know. Look in your binder.
It's not in there. I just did.
I don't know. You can get a blank copy, but as far as today, I don't know.
I finished it like the first day.
I believe you, but you need to find it.
Or wait, no, we had time to work on that last night.
I have a joke. You want to hear it?
I do, but now I don't. This class is going to start in 60 seconds.
No?
I tried turning
50
it in.
seconds.
Yeah.
52.
I literally
50 right now.
Yeah.
Do you know how to say sandwich in Spanish?
Sandwich?
Yeah.
Sandwich in Spanish.
Yeah.
Yeah, I just did it.
No.
I know how to say sandwich in Spanish. Sandwich in Spanish.
It's not. No, like, say sandwich the word in Spanish. The language.
I don't know.
Do you know what it? Do you want to know?
I won't remember.
Okay. Do you want to know?
Sure.
It's tacos.
Okay.
I got a PC, Mr. Townsend. I got a laptop.
Oh, I thought you meant parent contact.
On Saturday. Like a Dell.
It was in the
Imagine-
chemistry side of my binder.
Imagine that.
Okay.
So it was you. All right, good afternoon. I do need...
I got a 16.
Hello. How was your break?
That was good. I need assignments 45 and 46. Diego, please take a seat. Thank you. Most of you turned in 46 if you were here. That was the short AB review topic on Extrema. And then 45 was the Unit 9 review that you finished a few classes before that. I just never asked you to turn it in to give you points. But I did warn you before break. I know you forget about what happened before break, but I did warn you before break that I would be asking for those to make sure that you had them completed and ready to turn in. So take a moment, make sure you have your name on both of those. Give them to me if you don't have them, or I'm sorry, give them to me in the box as you find them. So what I would like to do today as kind of a easy first day back is I'd like to split up class into about 50-50. So about half of class, I'd like us to look at the start of the next topic. And then, instead of insisting that you finish that today like we would normally do, because you would have time to finish it easily, I am going to give you roughly the second half of class to look back at assignment 45. That's the one you guys are turning in. Because again, I do plan on giving you a test on that, and especially what you've had the 9-day break. You've forgotten what your strengths and weaknesses are. So I'm giving you some class time to make sure that you know where you stand with that. So we will have a Unit 9 test this semester. I'm leaning towards it being your semester exam, but I don't know. That will be to be determined later. Okay, so for our new part, assignment 47, this is the start of College Board's Unit 10. And you probably don't remember, but I told you that most students think Unit 10 is a little bit harder than Unit 9. Now, I would agree with you that the polar Unit 9 stuff is kind of tough, but the parametric and vector Unit 9 stuff was pretty easy. A lot of it was, you know, here's a vector, take the derivative of both parts, piece them together, and you've got the derivative vector, that type of stuff. Whereas Unit 10 is a lot about series and sequences, and you can see even from this one, they start off by saying recall, because in theory you're supposed to learn about series and sequences in Algebra 2, but I know it's usually one of those topics that they push to the end of the year and then sometimes they don't get to. So there's a good chance you never saw anything about series and sequences. So this will be kind of your introduction to that, and we'll barely talk about hardly any calculus really, but that's the plan for today. Okay, so first up, this is a sequence. So a sequence is just a list of numbers. Sometimes you're given kind of like a little formula to go along with that. So this is the formula that provides the sequence. So a sub 1 means the first term. So if you plug 1 in for n, you get 1 plus negative 2 to the first, which becomes negative 1. So a sub 1 is negative 1. Ben, can you put that up, please? A sub 2, the second term, is when n is 2. So they plugged in a 2 in for n. 1 plus negative 2 squared is 5. That's where the 5's coming from. So here's a sub 3, a sub 4, a sub 5. A sub number tells you that item number. The nice thing about this is, now this is strictly hypothetical, but if I want the 100th term, I don't have to figure out the pattern here and then keep on doing it until I get to 100 terms. If I want the 100th term, I can just plug in 100 in for n. Now that's an extremely big number, but it's whatever that comes out to be. So if you really just care about way down the road, that's where that formula can be kind of nice. Okay, so a sequence is really just a collection of numbers. I don't know if you'll get to this question today, but there is one that refers to this. I believe this is called monotonic, is how I believe you would pronounce that. I'm not sure. Basically, to be that, your sequence either never decreases or never increases. So your sequence is always getting bigger or always getting smaller to be called that. But that's basically just a vocab term. We don't really need that too much. Okay, we will be looking at some infinite series. So an infinite series means you're going to go to infinity. So this little symbol, this is called the sigma symbol. You did see this symbol in AB when you first learned how the definition of an integral. It was like you want an infinite number of rectangles, you want to add up the area of each rectangle, and then we did like length times width. You remember talking about that? Yes? Okay. Everyone says yes except for Leo, but that's okay. Anyway, so this is the Greek symbol is called sigma, but what it's really about is adding stuff together. So if you plug in 1, you get the first term. Then you start with whatever this says. Then you plug in the next integer 2, and that's where you get the second term. Then you plug in the next n would be 3, the next integer, that gives you the third term. But the sigma means you're going to add all of those together. Sigma is why it's adding all of those. And then you stop when n gets to this number. So an infinite series is when it goes on forever. So as much as we may want to do something by hand, just like brute force, take all the terms and add them up, you can't physically do this with infinity. You can't add up an infinite number of terms. Okay, so we're about to write this down, but a sub n refers to a specific item, whereas s sub n refers to a partial sum. So if I want to know how much the first 5 terms added together are, that would be like s of 5. You would find the first 5 terms, add them together, and then that would be what s of 5 is. So s of n, so for some generic n, you would take the first term plus the second term plus the third term plus ... all the way to a sub n until you get to that term. So I just said this, but a sub n is when you're talking about the nth term in a sequence. Whereas S of n refers to the sum of the first n terms. Okay, so using this example to make sure you understand, what do you think A sub 4 is? 8, because it's just talking about what's the fourth item in the sequence. A sub 4 is 8. How would I find S of 4?
You would add everything up to
Right, so add up the first 4 terms, and S of 4 would be 20. Okay, so basically just getting down some notation and stuff that we're going to use. So last thing you need on here, and we will refer to this again before class is over, but one way you can deal with infinite limits, since you can't physically write out an infinite number of things and add up an infinite number of things, you don't have enough time in your life, you need to know that this is the same as doing the limit as n approaches infinity of S of n. So if you have S of n, which is the partial sum, you can take the limit as n approaches infinity of the partial sum, and it tells you what that equals up to. So that'll be important before it's all said and done. Okay, on the next page. So, same old stuff. Nth partial sum is S of n. If the sequence of the partial sum goes to a number, we say that it converges to that number. So both of these are converge. So converge, diverge came up a little bit, came up for just a question or two earlier this year. But basically, if you add up an infinite number of things and it gets closer and closer to 2, we would say that it converges to 2. Whereas, if the partial sum diverges, then the series is also going to diverge. So to diverge means that either it's not going to a specific number, so it's unbounded, like positive infinity or negative infinity, or if it just doesn't settle on a certain number, does not approach a specific number. Okay, so we got 3 examples here to give you an idea of what some of the questions will look like. So the first question, does this series converge or diverge? So the first tip I would give you, especially the first couple weeks, so we're not going to get anywhere near finished Unit 10 before our winter break, but to kind of make this feel a little bit more comfortable, start writing out the first couple terms. You start at n equals 1, plug that in, you get some value. That's what S of 1 is. That's the sum of the first term. You could plug in 2, and you would get 1/4. So the partial sum for 2 would be the sum of the first term plus the sum of the second term, which would be 1/4. I'm going to write that as 1 over 2 squared, though. The third term, that's when n is 3. You plug it in. You would take the sum of the first 2, which I've already done, is 3/4, and add the third term, 1 over 2 cubed. I don't know, maybe one more. And then the fourth term would be what all of this is, 7/8, plus what you get when you plug 4 into this. So we go from 1/2 to this is 3/4 to this ended up being 7/8, add the first 4 terms together, you get 15/16. So it's fine, and sometimes you can make a reasonable guess. So when n is 1, the partial sum's a half. When n is 2, the partial sum is 3/4. If you add the first 3 terms together, they add up to 7/8. You add up the first 4 terms together, you get 15/16. So if I do that forever to infinity, do you have a guess on where you think that would settle? It does approach 1. So sometimes it's not too hard to kind of guess what's going to happen. Now, sometimes it's not going to be a nice whole number like that. Sometimes it's not going to work out that way, or maybe you just didn't see it. So, one way that you could go about this, and this seems a little convoluted here for just a second, but just hang with me and make sure that you write the notes down. So you could say the partial sum was, I had the first term, and then I had the second term, and then the third term, and then you add up forever until you get to 1 over 2 to the n. Now, you're not going to understand why I'm doing these next couple steps for a second, but again, just hang with me here. If I divide both sides by half, this becomes 1/2 the partial sum. And if I'm dividing this by 2, I need to divide all of these by 2. So what is 1/2 divided by 2? 1 what? Okay, and I'm going to write it like this. And 1/4 divided in half would be, okay, 1 over 8 or 1 over 2 cubed. And then you could keep doing that until, and we're going to do that one more than this. So if this goes to n, one more than that would be n plus 1. Now I'm going to subtract these two. If I take the partial sum minus half the partial sum, just by combining like terms, if you take 1 s of n and subtract half of s of n, this is going to leave 1/2 s of n. But the reason I'm doing this, and again, it's still kind of hard to see, but if I take all the s of n stuff and subtract the 1/2 s of n stuff, notice how these two cancel and these two cancel, and then this next one would cancel this next one, and this one would cancel this one. So in the end, you're really just left with a 1/2 and the last term, whatever that is. Sorry?
Shouldn't be 1/2 subtract 1 over 2.
Oh, yes, you're right. I'm sorry, subtract. I'm subtracting, subtract, sorry. Okay, and then finally, one more step, and then you'll see how this actually is helpful to us. We could multiply everything by 2, and the partial sum is 1 minus 2 over 2 to the n plus 1. And I'm interested in what is the partial sum if n goes to infinity. And that's where it goes back to that thing I had you star on the front page. If I want to know what's the partial sum as n goes to infinity, I could try to plug infinity everywhere there's an n. So this stays 1. When I put infinity in here, what does that fraction go to?
0.
So you were able to guess that that was approaching 1 because it kind of made sense. You were adding half the number as the time before. So you go half, 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 add them all up. Eventually you get to 1. But this process of saying, here's what the partial sum is, out to n, divided in half so that I can subtract those so I know what half the partial sum is, multiply everything by 2, and then you can just take the limit as n approaches infinity, and then there's no guesswork needed. So again, not the most intuitive process, but you do need to make sure you have that written down, because you will need that for number 7, I think. I think it was number 7. Okay, and then the last two are significantly easier, but we do need a calculator for number 3. So if you don't have a calculator, come grab one of mine real quick, please. Okay, so basically what this is coming out to is this first one's, we're adding the first 200 terms. So in theory, could you find the first 200 terms manually and add them together? Of course, but no one wants to do that 200 times. And certainly no one wants to do that 1,000 times. But you still need to be able to use these and approximate these. And this actually is kind of helpful to the last question too, which I'll go back to in a second. But it's only helpful if you know how to do this in your calculator. So in your calculator, it has that Sigma button in a few different places, a few different menu items. I know it's in alpha window because I see it all the time when I use the derivative and integration. Right above that is number 2 is for summation. So if you hit enter on that, it will put that symbol on the front screen for you, the home screen. So you could do,
Please continue.
I'm just afraid you're going to break dance again, that was all.
That's reserved for advisor.
Okay, so if I want to add the first 200 terms, I'll put a 200 up there. I'm going to start at x equals 1 or n equals 1. If you really want to put it in there, you can. And then this was the sequence. It's 10 over n times n plus 2. Now again, notice I'm using x, which is fine. If you'd rather use n, you just need to be consistent. If you put it in here, you need to n here and here. If you want to use x because it's easier to type in, this button right here will give you an x. Just make sure they're all x's. So when I hit enter, my calculator is going to plug in 1, get a value. Plug in 2, get a value. Plug in 3, get a value. It's going to do that 200 times, and then it's going to add all those up. So when I hit enter, you need to see that this is pretty taxing on the calculator. So I'm hitting enter right now. And it's thinking about it. And it's about 7.450. About 7.450. So type that in your calculator. Make sure you get the same thing. If you're not getting that, you need to let me know here in a bit so I can help you get that straightened out. Okay, the other part of the question wants us to find the first 1,000 terms. So actually you could just go from 201 to 1,000 and then add this, but I'm just going to have it do it from beginning. Now if you don't know that trick, if you guys hit second enter, it'll pull up the last thing you typed in, and then if you just need to change the number, it's easier than typing the whole thing in. So that's how long it took for the first 200 terms. Enter. Now for the next, or for the first 1,000 terms, again, that's a lot of work for the calculator to do. It's plugging in integers, and notice it's really not that much different. Why are these so close, though? It is converging, that's true.
Because it gets smaller as it goes.
Right. as you plug in bigger values in for x or n, you see how your denominator's getting bigger, which means your fraction's getting smaller. So each term is getting smaller and smaller and smaller and smaller. The terms from 200 to 1,000 are almost zero. They did almost nothing. So that one comes out to be about 7.490. Okay, and then the one thing I wanted to go backtrack, because obviously you need to be able to do this for some stuff, but let's go back to this question. Now, on your AP exam, they will ask you to deal with this without a calculator, but when you have a calculator, and I specifically remember doing this in college, I've asked my calculator to go from 1 to infinity. I'm looking back at question 2 for 1 over 2 to the n. But how do I get my calculator to put in a infinity there? Good, you can't. Your calculator doesn't let you put infinity in. But if you put in a big number like 50, even 50, the decimal's already rounded to 1 because it gets there so quickly. Even if you just add up the first 10 terms, I bet it's yeah, you can see, even if you just add the first 10 terms, you can see how it's almost 1. So if you had a calculator and you were asked that question, sure, you can't plug in infinity, but you can put a pretty big number there, and it is giving you a hint about which way you should go. So again, that's when you have a calculator, you can kind of deal with it that way. Okay, last one, and then we'll look at one more together as you guys practice it, and then I'll have you do a few more until we reach the halfway point. Okay, look at this guy. Do you think that series would converge or diverge? Okay, I agree. If you don't see that it diverges, take my advice that I said just a few minutes ago and make yourself write out the first few terms. If you write out the first few terms, you can kind of visualize what's happening. First, you plug in 1 for n. This is summation, so we're going to add all these together. Then you plug in 2 for n, you get 2. You plug in 3 for n, you get 3. You plug in 4 for n, you get 4. If you do that forever, what is that approaching? Which is not a number, so therefore it diverges. To converge, it has to approach a specific number. It has to get closer and closer and closer to 1, like we saw in question 2. Is that okay? Okay. All right, try question 1. See what you get. Now, question 1 does have 5 answers to it. It's wanting you to do 5 things. So, I'll give you a couple minutes to do that. I'll share my answers and talk about how I came up with that. And then I'll let you work a little bit further, and I will share a few more answers based on how much time we have. Again, I will not go past the halfway point of class, though. Okay, are y'all saying that you're done? Okay. Let me share my answers, and if you got the same answers as me, you can move on to question 2, and if you didn't, you need to follow me and watch me go over this one. Okay, so those are my 5 answers. So for the most part, it's really just being able to read this and know what this is asking. So S of 1 means it wants to know the sum of the first term. So if you plug in 1, you get negative 1 to the first, which is negative 1. That's how I got that answer. S of 2 means the sum of the first 2 numbers. So you got to take S of 1 plus what you get when you plug in 2 into this sequence, which would be negative 1 plus 1, which comes out to be 0. S of 3 just means add up the sum of the first 3 terms. So that's going to be the sum of the first 2 plus the third term, negative 1. S of 4 means the sum of the first 4 terms. So take the sum of the first 3 terms and then add the 4th term, which you find by plugging in 4 into this sequence here. So you get negative 1 plus 1, which is 0. And S of 5 just means find the sum of the first 5 terms. So if you're keeping up with this work, then I feel like it's a little bit easier. But I can just take the sum of the first 4 terms plus the 5th term, which ends up being negative 1. And that's where I came up with that answer. Okay, everybody okay with number 1? Okay. Okay, if you have not started question 2, please do question 2 next, and I will share my answers on the board, and I would be happy to go over it if you need me to, but I'll give everybody a minute to make sure they have tried it first. Okay, make sure you get those answers for number 2 before you go on to number 3. And after a few minutes, I'll offer to work it out if you need me to.
One always greater.
Okay, would anybody like me to work out question 2 or any parts of question 2?
You just add them,
Well, yes. The sum of the first term, the sum of the first 2 terms, sum of the first 3 terms, yeah. The arithmetic's a little heavy there, but... Okay, my answer to number 3 is that it diverges. So make sure you get the same thing before you go on to question 4.
Is this approaching infinity?
It's not approaching infinity, but it's not approaching the same number all the time. Write out the first couple terms,
Oh, yeah.
and then you'll see.
It can be like either way.
I mean, those are different ways.
I am passing back your Unit 9 review since I'm asking you to look over it second half of class. It has a grade out of 5 points, which doesn't seem like a lot for this much work, but I'm just reminding you that I gave you 5 points the first time you worked on it, just for working on it during class. So this is actually the second set of 5 points.
Because cosine.
Because it's like monotonic, boundary means it can't reach a certain value.
Cosine x means it never decreases more time. So if it is always decreasing, then it can't. Like if it's a big like monotone means it either increases or it decreases the whole time. But
Just cosine and not.
I think we had a little conversation about how, I can't remember.
Sorry. I'm just, it wasn't in my binder, and,
It might be in the graded box.
okay.
I do have a grade for you on it.
Huh?
I do have a grade for you on it.
Okay. I was just, yeah, I wanted to, because I thought I did. Oh, yeah, I did.
Take it back. I just haven't had time to pass this back yet.
You're only on 10. You don't know what 10 is.
Okay, does anybody need me to explain why number 3 diverges? Okay, my answer to number 4, there was a lot more debate about this one in first period, is 1/4. I will tell you the mistake that my first period made is they took all of this and plugged it in here and then plugged this in the calculator but put a really big number here. That doesn't work because this says A sub n and this is S sub n. they've already found a formula for you based on the number of terms you have. So don't do what they did. Also, you shouldn't be trying to use the calculator there anyway. So, but same thing. Let me give you a few minutes to try it on your own first, and then I'll go over it.
It just means that term isn't the sum, it just means the term.
I was just kind of
this.
Why wouldn't you do Does B not work as well? Does B already work?
It would be using bounded just reading up the terms.
What, less than what? What number is less than? Wait, did you only plug in cosine and cosine and over?
No, it's perceived always less than 3.
Less than what?
It's always less than 3. Yeah.
Period. It's always less than what?
It's always less than 3. Because if you plug in
I still get full credit because most of it was just I didn't plug it into my calculator.
This one?
Oh, except for that one, but the other ones I just didn't plug it into my calculator.
You didn't have time to do it
Oh no, I did that.
before the break?
I'm pretty sure I did it on like a separate piece of paper, but I just didn't put it on that one.
I'll give it to you this time, but next time you need to make sure you attach the other piece of paper.
Thank you.
He's right. He's right. What?
You're adding positive numbers all the time, so it's only
I just put A if n plus 1 is always greater than if n.
Yeah, I'm going to go over it on the board.
Yeah.
Give me just a minute. If you're stuck, stay.
I don't know. But
I am going to go over number 4 on the board. We had a lot of debate.
Oh my God.
Not a lot. A lot of people struggle with that.
I'll give this
What are you doing?
the second one.
This
500.
Oh wait, you could just do this. Just plug in n plus 1.
What?
Plug in n plus 1.
I mean, that's what I did.
Then you just 3 plus 2 must be 1 plus 2 and so on. You just plug it in. But that's
Figured.
it doesn't reflect that.
No,
I
it's
don't
just.
know. I just
Well.
500 is 3.65.
Wait, yeah, should be that. Should be that.
Okay, if you are unable to figure out 1/4 on question 4, let me say a couple things about that. So first off, this is an infinite sequence because I can see it's going to infinity. So I'm adding up an infinite number of items. If you look back at the front page, I said that this is the same as the limit as n approaches infinity of s of n. So they've already come up with a formula for you for the partial sum. You could, well, you don't even know what a of n is, but if they gave you the sequence a of n, you could plug in 1, get the first term, plug in 2, get the second term, plug in 3, get the third term, plug in 4, get the fourth term. And then you could try to come up with a formula that gives you the sum for however many terms you want. They have done all of that. You just need to recognize that this is the same as this. So your answer should have come from taking the limit as n approaches infinity of this And to me, that's a quick question, but it depends on if you remember your infinite limits from AB. I'm calling this an infinite limit because it's approaching infinity or negative infinity. So, what's an easy way to find the limit as n approaches infinity of this? Good, very good. Horizontal asymptote rules. Because horizontal asymptote is a way to describe the far right and far left of the graph, which is when n approaches infinity or n approaches negative infinity. So because these degrees are equal, horizontal asymptote rules say it will approach leading coefficient over leading coefficient. Now, I think that this is a very roundabout way of doing this, but somebody suggested this first period today, and so I will share that with you because, I don't know, you might like their method better than using horizontal asymptotes. They factored an n out of the denominator. So n times 4 gives you 4n, and n times what gives you 1? 1 over n. Then you could reduce the n's. Now when I try to plug in infinity into this, what's 1 over infinity go to? So your answer comes from 1 over 4 plus 0, and you could get 1/4 that way too. So that's a pretty creative way to go about it, but again, you really should know your horizontal asymptote rules anyway, which you can always apply if it's a rational function, it just means a big fraction, and you're approaching infinity or negative infinity. So, again, quite a bit there, but just make sure that you realize that these two are not the same thing. First period, a lot of people plugged this in here, plugged in a big number, threw it in their calculator, and it was getting a humongous number. It was getting bigger and bigger and bigger. But this isn't A sub n, it's S sub n, so you can't do that. Measuring two different things. Okay, I know the next one's just calculator based, but let me share my answers to that, and then I will check our time here. Obviously, when it says use your calculator, make sure you round to 3 decimal places. Okay, and okay, so we're close to halfway point. So at least finish question 5. Make sure you get these 3 answers from your calculator. Then you have the whole second half of the class to look at your Unit 9 review. I hope that you don't feel like you need the whole second half of the class to look it over, but I'm giving you some class time to do that, partly because it's a break, partly because you still have a test on it sometime in the next couple weeks. Obviously, I'll warn you before it happens. But if you really need that time to look over your Unit 9 review, you don't have to do any more of this assignment past question 5 today, unless you just want to get ahead on it, or if you don't have to spend much time on your review, then you can work ahead. But that's the plan for the rest of class. So again, I'll leave this up for a minute and then switch back to the agenda.
That's the one. That's the one that we cancel out.
Wait, were you being serious when you were talking about that? I did one thing. Or actually, like, two presentations.
Oh, gosh, I should have got it. Is that
If you do choose to work ahead on this assignment 47, I've worked all but one of them. And if it's bugging you without checking your work or something, you're welcome to come look at my paper.
So it's
is he serious? Or like, I can't tell.
how much for that? How much for this? $50? Okay. Okay, yeah, that's pretty good. There's Cyber Monday. Oh, wait, I have them right here. I'm getting them. They're coming on. Okay, these are classics. I got these for 84. Here, you didn't know the retail price though.
250.
From Kovacs.
Pro Max is like $60. Wait, do you go to the retail website?
No, I just wanted to, they felt really good. The retail price is 160. So it's a pretty good deal. It's a
So
pretty
wait,
good deal.
there's a shoe review website. I want to use it. That's run for Yeah. Wait, what shoes do you
I
use?
just upgraded.
What shoes do you use for running?
Right now, so I'm trying this new thing where I'm rotating. And I'm getting, don't buy ones, don't buy ones. Never
What are
buy
your
ones.
favorites?
Hook up the foot to 9. Those are my favorites.
Let's see what they have made. 87.
But look at the back, bro.
They have the back.
There's a pair that I really love.
We might as well.
It's also
Which of Vaughn could be the impartial for the Infinite series?
I really love it.
That's terrible.
Wait, what's the
We did.
Yeah, what's the highest?
What is it running?
Why would you divide by the third?
Third Okay, the thing is,
The highest is 87. Oh, there's only 2 results.
Oh no.
C. Isn't that B?
okay, the thing is,
Or isn't that B?
support shoes, which are also
The Infinite series is a code version of the sum of
cushion shoes.
which could be the impartial sum. So which one approaches the
That's what
They have an objective audience and stuff.
It's
you
either
can rate them by the type of shoe.
It's
The best one is Skechers Go.
Where's Townsend?
Why does Reddit
disappeared for like
Reddit
7 minutes.
No, but they like test, they actually like test them. Like they
Oh,
don't, it's not,
Patrick, I only listen to Reddit.
it's objective, it's not like subjective. Like they actually test.
Okay, the thing is,
Now I saw this interesting video on why product ratings were
wait, what other shoes?
It's a net 1 card.
Oh,
0 drawback.
They never use them, bro. This is gonna be
Well, you didn't buy them?
No. Wait, how about the Salomon arrow going
I
to?
heard Salomon was a good trail.
Wait, what's the difference between the bottom
Here's
one?
like
Just the two, right?
Let's ask.
ASIC Magic Speed.
We can just plug in.
It is a very unstable
I don't
shoe.
think it's A or B.
The Skechers.
Oh, that's a subjective rating. Okay, whatever.
Maybe it's talking about schedule.
Everything is subjective.
So,
This is true.
Nikes are always heavy.
and the only difference is the same.
It's all just
Mr. Townsend, what do you recommend I get on Steam? Like, do you have any game recommendations?
Why on Steam?
Because I just got Steam. I just got a laptop.
I would recommend not buying anything until you're ready to play it. I would recommend not buying anything until you're ready to play it,
Yeah, I know.
because games just get cheaper.
There's like a huge sale right now.
Yeah, but they still get cheaper all the time.
But they tested they
I need to do the wish list, I guess.
So which one only?
yeah.
Okay, that means it's not. That means it's not.
Well, it depends on where you're willing to buy games from. If you only buy through the Steam client, you won't get that good of deals. They're okay. If you're willing to buy from other sites, they're much cheaper, and you can still add them in Steam. So, as far as games, I don't know. It depends what kind of game. What's your favorite type of game?
I don't really know. I don't really have a preference.
Well, I would get the Epic game launcher. It's like Steam, but just different company. And I would definitely get Brotato while it's free. It's only free for a few more days. I've been playing that for the last month or two. It's a lot of fun. Yeah. Although it's probably better with the controller, so you might want to sync the controller to yours. But it's free, so I would get it. And then they do like a game or two free every week, so I would just always start claiming those. The other... Come here a second. The main site that I go to, but again, I don't mind buying stuff elsewhere, is if you do gg.deals, scroll down. So, new deals, whatever, best deals. So just based on history, I like to look at these. So, here's some games, and like, these are historic lows for the game. Here's Brotato's free right now, ends in 2 days. And it just shows you, like, these are the games that are on sale, and these are the cheapest they've ever been. But you got to buy the key somewhere else usually.
Yeah.
Part of this issue is
Audience for. I can click here.
these are official sites. So this is like Steam and places like that.
Yeah.
So these are a little more expensive. These are like gray market keys. So they're a lot cheaper, but it might be a stolen credit card and they might pull your game someday. But that's a quick place to just kind of see like what stuff is actually worth and like what's actually cheap. So I do that. I check that every day just to kind of see if there's anything new. You have Amazon Prime at home? Okay. If you do Prime Gaming, I don't know if this will pull up. They give a ton of free stuff away. So look, right now you can get this game for free on Epic, this game for free on Epic. Do you know what GOG is? It's like Steam, it's a different Steam. They're giving that game away free, but you got to put it on that one. Here's another game free. Okay, now this one you have to play through Amazon, and I'm not crazy about those. Like, I think it's cloud gaming or something. You can mess them up if you want to. Free. That's why this game was so cheap on the other side, because people are getting it for free here.
Yeah.
Free game, that's a good game. Free, I mean, there's like 10, 15 games, and those change every month. So if your parents have Prime account, you just have to log in, click claim game, and there you go. So I wouldn't buy a lot, honestly.
Yeah.
I would claim everything free that I could, and maybe buy one game that you think you're actually going to play. And don't worry about the Steam sale, because games go on sale all the time.
Yeah, you're right. I got Terraria for like $4.
If you want to play I don't know how much Stellaris is on sale for.
The Lars?
Stellaris. It's a
Oh.
it's a super
10
massive
bucks? Yeah.
world building.
I've bought the game twice and I've never played it. So I bought it on PC and Xbox, and I still never get to it.
I have the base game right now. Getting the full, like, with all the DLC is so expensive. So I'm just very slowly accumulating the DLCs for Stellaris. Because it's not, I don't play often enough right now to warrant me buying all the DLC right now.
You can buy this base game for about $8.
Yeah.
I didn't finish number 7 because I started it wrong and then I ran out of time.
I'm thinking of getting Risk of Rain 2. Is that worth it?
It's a good game.
It's on sale for like $9.
It's a fun game. I have it.
Okay, this one is the one that I started wrong and I was going to come back to. I didn't though, or I haven't yet.
It's
Did
very
you get it here?
It's very much a roguelike.
Oh yeah, I'm 100%.
Yeah.
I'm just not used to 3.
It does take its
Oh,
time.
I didn't finish that either. Hold on. I've got the answers here, so.
You didn't put it on your website.
I know.
It takes a second to get used to it. It's
It's supposed to be C. 9, D, C, and then this one, the other one I hadn't finished, number 7 was 1/2 minus,
I think it's just 1/2.
that's not what they got. 1/2 minus 1/2 n plus 1.
But it says infinity. So that's of the power of 0.
Maybe that's why I skipped that one. When it says what's the nth partial sum, that kind of implies that you should have n's in your answer. So, like I said, that's probably why I skipped that one. I probably started it and then.
But also this one has n partial
Plug in, you don't sum. Why not?
That's true. Let me see if that's what they got.
Oh, it's S event. Okay, that makes sense.
Yeah, I guess that makes sense. I would go with that. That makes sense. Because they did consistent there. But yeah, a lot of times when they say nth partial sum, they're kind of implying that n might be part of your answer. So. I need to finish it. But basically, don't buy a bunch of games.
Yeah, I wasn't planning on
I have like 700 games on Steam, and I've played very little of them. It's a lot of money. I wish I could get back.
all the games I have I play.
I have like
Because I've got Skyrim, I've got Fallout, I've got Terraria.
Oh, should I get New Vegas? It's on sale.
For how much?
Not until you're ready to play it.
I mean, I don't really have a bunch of games that like, or I have like 3 games. One of them was free.
Yeah.
So like,
If you claim all those free games on Prime, you got stuff to play for
yeah.
6 months, probably.
It's just I've been wanting to play like Fallout, but I haven't.
If you're gonna start playing Fallout,
Probably play 3
you want to
first.
start with Fallout 3.
Okay, that's also. I
Oh,
think
man.
there's a huge Bethesda sale right now.
I wish I could play Fallout 3 for the first time again.
After if you play Fallout 4 first, it's just not as good.
Yeah.
Because so many of the quality of life mechanic changes that happen.
4 was fine. I didn't love 4.
4's story is not great.
Yeah.
So a lot of the mechanics are a lot better, but like the story and the quests and the world building not as good.
Arkham Origins is $4.
For this one,
That's the only one I haven't played. That's the only one I haven't played. I played the trilogy
No.
on
Why not?
Okay, so you start with
I've never
1.
played any of
You
them.
plug it in, you get 1.
I know, but it approaches to -1 over 12.
No, it doesn't.
I've
It
never
does.
played any of
No,
them.
it doesn't.
Yes.
You plug in 2, you get 2. You plug in 3, you get 3. You plug in 4, you get 4. What's 1 plus 2 plus 3 plus 4 plus 5 plus 6 forever?
It's -1 over 12.
No, it's not.
Yes.
No. Not even close. It's infinity.
I'll try it.
It's the Rayman guess.
Huh?
The
like
Rayman
Spider-Man
guess.
with Bill Gates.
I'm not sure what's the name of it.
Riemann sum?
No, it's the Rayman guess.
Random guess?
No, Rayman.
Rayman.
Anyway.
Yeah, but I buy a lot. I like to get a lot of games on Steam because I have it set up where me and my wife are like family or whatever, you know. So if I buy a game, she can play it too. So then I don't feel so bad. I bought her. You know what Minesweeper is? There's like a Globe one now, like a Globe Minesweeper, and it was like $1.50 or something. So I bought it, and she's been playing it for like a month. So, and it was $1.50.
There's a my friend had got it to download. It was great. First person shooter chess. 5D chess is a good game. It's
Huh.
real confusing. So confusing.
Well, yeah, I mean,
5D chess makes like no sense, but it's fun.
my mom just bought me like a 16-inch Dell laptop.